Good morning, students. Today we are going to start a new lesson, that is atomic structure. First we will see smaller introduction about the atomic structure. So every substance that is surrounding us is made up of a unique sum of the elements. So each and everything is made up of a small elements. So totally we are having how many elements? Totally 118 elements. So that elements that is identified by the worldwide. So out of these 118 elements, in that 92 elements that they will be occur by nature. So remaining elements that is synthesized by the laboratories. So 92 elements only occur by nature. Remaining elements that is made by the laboratories. So copper, iron, gold and silver are some of the elements that is found in the nature. So the elements like technetium, promethium, neptunium and plutonium. So these are the elements that are synthesized in the laboratories. So each element that is made similar, that is minute particles, that is called as atoms. So atom is a very smallest particle. So each and every atom they will be having any one of the elements. For example, the gold is made up of the gold atoms, so that it determines its characteristics. So the word atom that is derived from the word atomos, and then atomos means atomos means smallest indivisible particle, and atomos, that is a what is that? Atomos is a smallest indivisible particle. So the ancient Greek philosophers, that is like a Democritus, that they have been spoken about the atoms. So these are small introductions about the atomic structure. So next we can see the Dalton's atomic theory. So the John Dalton provided, that is the basic theory about the nature of matter. So he proposed a model that is known as model of atom that is known as the Dalton's atomic theory in the year of 1808. So what are the main postulates of the atomic theory means? So what is the first point means? The all matter that is made up of extremely small particle. So everything that matter is made up of a extremely small particle, so that is called as the atom. So then next point, atoms are the same element that is identified in the all aspects. So that is the what are the identical means? Size, shape, mass and properties. So next, atom of different elements, they will be having a different sizes. Atoms of different element, they will be having a different size, mass and they possess the different properties also. So each and every element they will be having a different size and different mass and different properties. So the atom can be neither created nor destroyed. That is atom is indestructible. Next, the atom of different elements that it may be combined with each other in a fixed simple ratio to form molecules. So they may combine together to form different molecules. So then atom is the smallest particle of matter and that is taking part in a chemical reaction. So that it will be taking part in some of the chemical reactions. So next we can see the advantages. What are the advantages of the Dalton's atomic theory means? So the Dalton theory, that is explaining about most of the properties of gases and liquids. So it explains mainly about the properties of gases and the liquids, and then it explains the laws of chemical combination and the laws of conservation of mass. So this we can see in the last topic of the lesson. So then next, this Dalton's atomic theory, that is helps to recognize the molecular differences between the molecular differences of elements and the compounds. We can recognize the molecular difference of compounds and the elements. So next we can see the limitations of Dalton atomic theory. So the atom is no longer, and that is considered as the smallest indivisible particle. So atom is the smallest indivisible particle. So the atoms of the same element that is having a different mass, so that is the isotope. So next, isobar. The isobar means atoms that it will be having a different elements and they may have a same mass. So this is the isobar. Next, substance that is made up of same kind of atoms and they may have a different properties. For example, coal, graphite and diamond. So these are made up of carbon atoms but they differ their properties. So these are made up of the carbon atom but they will be having a different properties. So these are the limitations of Dalton's atomic theory. So next we can see the fundamental particles. So fundamental particles in 1878, Sir William Crookes while he conducting an experiment using a discharge tube. So in that he found the certain visible rays that is traveling between the two metal electrodes. He found the visible rays, which is a visible rays that is traveling between the two metal electrodes. So that rays is known as the Crookes rays or cathode rays. So the discharge tube is that is used in the experiment that is referred now as a Crookes tube, or more popularly we are saying as a cathode ray tube, that we will be saying as a CRT, otherwise cathode ray tube. So this is the cathode ray. So inside that is a cathode, that small daughters, and one side is a cathode ray, another one side is a anode. So the inside of what is filled with that gases at low pressure. So the what rays is passing there means cathode rays is passing. So here high voltage. So this is the cathode ray tube. So then we can see the what is this cathode ray tube, that is a very long glass tube and that is also filled with the gas and it will be sealed at the both end also will be sealed. So and it is consist of two metal plates which will be acting as a electrodes. So that is connected to the high voltage. The electrode which is connected to the negative terminal of the battery and that is called as a cathode. So the cathode is a negative electrode. So the electrode connected to the positive terminal. So the electrode which is connecting to the positive terminal, that is called as a positive electrode. So there is a side tube which is connected to there is a side tube and that is connected to the pump. So the pump is used for the lower the pressure inside the discharge. For that purpose only we are using the pump. So this is the fundamental particles. So next we can see the discovery of electrons. So when in the discovery of electrons, when a high electric voltage of 10,000 volt or more it is applied to the electrode of a discharge tube, that it will be containing air or any gases at the atmospheric pressure. So in that there will be no electricity flows through the air. So however when the high voltage of 10,000 volt is applied to the electrodes of discharge tube, that it will contain either air or any gas at the very low pressure of about low pressure of about 0.001 millimeter of mercury. So that it will be having a greenish glow is observed on the walls of the discharge tube. Discharge tube behind the anode. So this observation that is showing us clearly some invisible ray is coming from the cathode. So then these rays is called as a cathode rays. So later we have said this as a electrons. So next we can see the properties of cathode rays. What are the properties means? The cathode rays that it will be travel in a straight line from the cathode that is towards the anode. So these cathode rays that is made up of the material particles which is having a mass and kinetic energy. So cathode rays that is deflected by the both electric and the magnetic field. So this is the negatively charged particles. Cathode rays are negatively charged particles. So the nature of the cathode ray that it does not depend upon it will not be depend upon the nature of the gas filled inside the tube, otherwise cathode used. So this is the emission of electrons. So we are having the one end as a cathode ray and we will be having a bright spot. So inside that is a gas at the low pressure anode and the cathode rays, and then fluorescent material. So this is the diagram of the emission of electrons. So next we can see the discovery of protons. So the presence of the protons is a positively charged particle. So the presence of positively charged particle in the atom, that has been previously predicated by the Goldstein, and that is based on the conception of that atom, that is being electrically neutral in nature. That is what is it? Electrically, that is neutral in the nature. So that it should necessarily possess the positively charged particles to balance the negative charged electrons. So here Goldstein he repeated the cathode ray experiment by using the perforated cathode. First he applied the high voltage under the low pressure. He observed a faint red glow. He observed the faint red glow and the red glow on the wall behind the cathode. He observed the faint red glow on the wall behind the cathode. Since the rays that is originated from the anode, that they are called as the anode rays, or we can say as a canal rays, otherwise we can say positive rays. So the anode rays that were found in the stream of a positively charged particles. So next we can see the properties of anode rays. So all the properties that is very important: cathode rays, anode rays and the neutrons. So these properties are very important, so learn carefully. So what are the properties of anode rays means? So that it will be travel in a straight line, and the anode rays that is made up of the material particles. Anode rays that it will be deflected by the electric and the magnetic field. So they are deflected towards the negatively charged plate. So they consist of positively charged particles. So the properties of the anode rays, that it will be depend upon the nature of the gas which is taken inside the discharge tube, and the mass of the particle is the same as the atomic mass of the gas that is taken inside the discharge tube. So these are the properties of the anode rays, and this is the emission of protons. Before I said there is a red glow, faint red glow. This is the perforated cathode, and behind that we are having a red glow, and then air is at the very low pressure. For a top, what we are having the vacuum pump and the anode positive rays and the high voltage generator also. So this is the emission of proton diagram. So next we can see the discovery of neutrons. At the time of J.J. Thomson, he has only two fundamental particles, that is the proton and the electrons. We know that only proton and the electron. So in the year of 1932, James Chadwick discovered the another fundamental particle, and that is called as the neutron. So that is called as another one of first J.J. Thomson has only the two fundamental particles, that is proton and electron. After in the year of 1932, James Chadwick discovered another one of the fundamental particle, and that is called as a neutron. But the proper position of these particles in the atom, that was not clear. Still now we are not clear. Rutherford described the structure of the atom. So we can study the Rutherford atom model in the higher classes. So now next we can see what are the properties of the neutron. So the neutron carries no charge. Neutron always will be having it is a neutral particle. So and the neutrons has a equal mass. What is it? A neutron has a mass that is equal to the proton, and that is a 1.6 into 10 to the power minus 24 grams. So this is the mass of that. So thank you, students.